Alright, so in this video we will define something called the center of gravity, and we'll also see its relationship to what something called the center of mass. We'll see that they're basically equivalent to each other. Okay, so let us think of a simple situation. Let's say that I take a ball, a small ball, okay, tiny ball, and we toss it. Okay, we give it a kick or toss it, and we let it go at some angle. What we notice is that it would follow a parabolic path. Now, in projectile motion, we figured out the path. So we knew that this would be a parabolic path for the object. Okay, and the reason all this happens is because gravity is acting on this object, and it, makes it move along this beautiful curve. Now, on the other hand, if I were to take, say, a baseball bat. Okay, so this is my, baseball bat is a little messed up. Okay, so some extended object like this, and I were to toss this object at an angle theta once again. Okay, now what we notice is as this object travels, okay, this baseball bat would go along a certain arc. Okay, so what we notice is as this baseball bat is tossed, as it moves, this baseball bat is not only going to move along some arc, but it is also going to spin about some point. Okay, now if we were to look at this very closely, what we'd notice is that there'd be one point on this baseball, a special point on the baseball bat, okay, let's say it's somewhere here, which would simply travel along the same path as any projectile would have traveled. Okay, and what we would also notice is that the object would be spinning about this point. The baseball bat would actually be spinning simply about this point. Okay, so this special point is called the center of gravity of the bat, and it appears as if gravity is simply acting on that part. Okay, because that's the part that is simply behaving as this particle that was tossed. Okay, the rest of the object is simply spinning about that. Okay, and that spin is not really caused by gravitation. It is simply caused by the way the object was tossed. Okay, so this very special point is called the center of gravity. Now, if we were to repeat the same thing with some extended object on a surface, and if you were to exert a force on this extended object, then it would appear as though there would be one point on this extended object that would travel along a straight line path, okay, and then the object itself would spin around that path, and that point, that special point, we would refer to as the center of mass of the object. And what we know is that the center of mass and the center of gravity are identical points on the object. Okay, so let us see how to calculate the center of gravity. So I'll give you first a vector relationship, okay, and the center of mass or the center of gravity, okay, is also RCG, is simply equal to the before this I think I need to just tell you a couple things. If we take some kind of if we take our x and y axis, okay, and if I have a bunch of objects, all right, of different masses, say M1, M2, M3, and so on, and each one has some position, say R1, position vector R1, another one with position vector R2, and so on and so forth, then the center of mass is simply given by M1 times R1 plus M2 times R2 plus ... divided by M1 plus M2 plus ... Okay, now this is a vector relation, so obviously I can break it up into components, and the component part is very easy. The x center of mass or the x center of gravity is simply equal to m1 times x1 plus m2 times x2 plus so on and so forth, divided by m1 plus m2 plus ... And we can also write this as summation I to n, okay, mi xi divided by summation, so this is I equals 1 to n mi. Okay, and I can write the same thing for the y center of mass. The y center of mass would be m1 y1 plus m2 y2 plus ... divided by m1 plus m2 plus ... and this is obviously equal to mi yi I equals 1 to n divided by summation I equals 1 to n mi. Okay, so this is how we define the center of gravity. We could do this, write the same expression for a z coordinate, but as far as we're concerned, we'll just stick with the x and the y coordinates. And in the next video, we'll do a couple of simple calculations of determining the center of gravity.